Okay, I see some of you have finished up. Some of you are still working, and that's fine. We'll go over what you have so far. So convert to fraction form. Number one here is 73 and 1/3%. Now it already has a fraction in it, but it's in percent form. To turn it into fraction form, remember that becomes 73 and a third out of 100. And we have to then reduce that down. We have to get the fraction out of the fraction. We can multiply both by 3, or we can simply just divide this out. 73 and a third over 100 can be thought of as 73 and a third divided by 100. Now I'm going to make that 100 into a fraction by putting it over 1. And then to divide, I'm going to have to multiply by the reciprocal, so that means I have to have these in the form of an improper fraction. 73 times 3 is 219, plus 1 is 220 over 3. And then divided by 100 is going to be times the reciprocal, so times 1 over 100. Now as I look at this, both 220 and 100 can be divided by 20. 220 divided by 20 is 11, and 100 divided by 20 is 5. 11 times 1 is 11, 3 times 5 is 15. So 73 and 1/3% is the same as 11 out of 15. Number 2 here, 318.75%. That's 318.75 out of 100. Now I do need to get rid of that decimal, but before I do that here, I combined a couple of tasks. First, we notice that's bigger than 100%, so the equivalent fractional form will be bigger than 1. So I'm going to convert this down to a mixed number. 100 goes into 318.75 3 times, with 18.75 left over. So now I'm going to work with just that 18.75 over 100, and I'm going to get rid of the decimal there. Now, some of you may have noticed that 0.75 is 3/4, so you could have just multiplied by 4 to get rid of the decimal. If you don't notice that, the way that's always going to work is to just count the decimal places. There's 2 decimal places, so that means if I multiply by 100, it'll get rid of them. If there was only 1 decimal place, of course, you could have multiplied by 10. 3 decimal places, you would have to multiply by 1,000, and so on. So 18.75 times 100 is 1,875. 100 times 100 is 10,000. Both of those, the 1,875 and the 10,000, can be divided by 25. $1,875 divided by 25 is 75. Is that right? Yeah, that's right. 10,000 divided by 5 is 400. Well, both of those can still be divided by 25. 75 divided by 25 is 3. 400 divided by 25 is 16, and that's as far as it can go. But we do have to remember the whole number up here. That is 3 and 3/16. So in fractional form, 318.75% becomes 3 and 3 out of 16. Now going the other way, going from a fraction or decimal back into a percent. Number 3 here, 7/8, that's 7 out of 8. We want that to be out of 100. And we'll cross multiply. 7 times 100 is 700. Divide by the number that's diagonal to the missing number. Gives us 87.5%, or 87.5 out of 100, or 87.5%. Number 4, 0.083, well, that's in decimal or rate form. That means it's out of 1 to be out of 100, or to be a percent has to be out of 100, which means we're going to have to multiply by 100 or move that decimal point over 2 spots. That becomes 8.3 out of 100, or 8.3%. Any questions on those four? Okay. So we left off last week talking about benchmarks, and we use those benchmarks to do a couple of different things. We use them to double check our work, or at least to have an estimate of our work so we knew about where it should be. And we even use some of the benchmarks to calculate some relatively simple percents. Well, today I want to look at actually calculating those percents. And we're going to use two processes. We're going to use the proportion method first. And then I'm going to come back and use something called the rate method of percents. So notice I'm going to be leaving half of my screen blank. I'm leaving that space so that I can come back and redo the same problems using a different method. So the proportion method, remember, is like we had with the changing the fraction, converting the fraction back to a percent. We might have 3/4, and we have to change that to be something out of 100. And we cross multiplied and divided to find that missing piece. So let's take a look at a problem like find 35% of 80. To do this, first I always start with the percent. 35% means 35 out of 100. Now, before we continue here, let's take a look at what those two numbers mean. The 100 here is actually significant. That 100 means the whole thing, or what we refer to as the base amount. The base amount would be one whole object, or the beginning, the initial amount, where we started from. It's the amount that all the other percents in the problem would be calculated off of as a piece of that. The 35 then is the portion of interest. So the way you could think of this 35% is we have 100 items. That's the base amount. But we're only interested in 35 out of those 100 items. So now back to the problem. There are two other numbers in the problem. There's got to be one number given and one number that we're asked to look for. Well, here it says find 35%. So the number we're trying to find, the missing number, is the number that matches up with the 35%. Of 80, we can read that as out of 80. We can put the 80 on bottom here. Now to solve this, remember, we cross, multiply, and divide. So the two numbers that are diagonal are the 35 and 80. So we do 35 times 80, which is what, 2,800? And then the number that's diagonal to our missing number is the one we divide by. So we divide by 100. That gives us 28. So 28 is 35% of 80. So let's do a similar problem worded just slightly differently. Instead of find 125% of 48, we're just going to have blank is 125% of 48. Fill in the blank. Well, again, we're going to start with a percent. 125% is 125 out of 100. Now you probably noticed 125 out of 100 is a little awkward because the 125 is bigger than 100. And that's true. In this case, the portion of interest is actually that whole base amount plus a little bit more. So even though it's a portion, we think of that as being a piece of that base amount. In this case, it's actually larger than the base amount because it's more than 100%. On the other side, we still have to match everything up. Well, blank is 125. That's implying that our missing number lines up with the 125. Of 48, again, we can read that as out of 48. It implies the 48 goes on bottom. Now, before we even start here, we know what goes up here is going to have to be bigger than the 48 because we're dealing with something bigger than 100%. So we cross multiply 125 times 48. I believe that's 6,000. The 100 is across from the diagonal from the missing number, so we divide by 100. That gives us 60. 60 is 125% of 48. Now that makes sense because 60 is a little bit bigger than 48. 125 is a little bit bigger than 100. 40% of 70 blank. So we are looking at here, same type of problem, just worded very differently. We have the percent, 40%, so that's where we start. 40 out of 100 equals, well, of 70. Once again, we can read that as out of 70. It implies the 70 goes on bottom. It's out of 70. And then 40% is blank. It implies that that missing number goes with the 40. And once again, we cross multiply and divide. The two numbers that are diagonal are 40 times 70, 2,800. The number that's diagonal to the missing number is the 100, so we divide by 100, giving us 28. Well, let's do this one. 32 is 80% of blank. So this one's worded a little bit differently. It's a different piece missing is actually what it is. But we still have the percent, so we're going to start with that percent as always. 80% is 80 out of 100. On the other side, it says 32 is 80%. So 32 goes with the 80, so it goes on top. Of blank, again, you can read that as out of blank, implies the missing number goes on bottom. Now here, there's a different piece missing. It's the bottom number down here that's missing instead of the top. But the process is still exactly the same. We find the two numbers that are diagonal. In this case, it's the 100 and 32. 100 times 32 is 3,200. Then we divide by the number that's diagonal with our missing number. We're going to divide by 80. 3,200 divided by 80 is 40. So 32 is 80% of 40. So even though it was different pieces missing, it was the exact same calculation. Cross, multiply, and divide. Or we might have something like this. 30% of blank is, oops, that should be 51, not 52. %30 of blank is 51. So again, we start with that percent. 30% is 30 over 100. Now on the other side, again, we have to match the numbers up. Of blank, if we read that out of blank, implies that missing number goes on bottom. 30% is 51, implies that 51 goes with the 30. So now again, we cross multiply and divide. The two numbers that are diagonal are the 100 and the 51. That's 5100. The number that's diagonal to the missing number is the 30, so we divide by the 30. 5100 divided by 30 is 170. 30% of 170 is 51. Then we can run into ones like this. 63 is blank percent of 70. Well, I've said in all the previous problems that we always start with the percent. Here, however, we're missing the percent. But it doesn't matter. We're still going to start with the percent. The percent's missing, so it's going to be just blank over 100. And now we match things up. 63 is blank percent. That implies the 63 matches up with that missing percent. So that goes on top on the other side. Once again, of 70 can be read as out of 70, implying the 70 goes on bottom. Now, once again, the missing piece is in a different spot, but the process is still exactly the same. The numbers that are diagonal with each other, the 100 and the 63 are diagonal with each other. They multiply to make 6,300. Then divide by the number that's diagonal with the missing number. So we divide by 70. That gives us 90. So 90 out of 100, or 90%. 63 is 90% of 70. Once again, the percent is missing. Blank percent of 40 is 8. So the missing percent is blank out of 100. Of 40 can be read as out of 40, implying the 40 goes on bottom on the other side. Blank percent is 8, implies the 8 lines up with the missing percent. And once again, we just cross multiply and divide. The two numbers that are diagonal with each other are the 100 and the 8. So we multiply them to get 800. The third number that's diagonal with our missing number is the 40. We'll divide by that. 800 divided by 40 is 20. So 20 out of 100, or 20%. 20% of 40 is 8. I really like the proportion method. I like it for a lot of reasons. The big one is, or one of the big ones is, it's always the same calculation. No matter what piece you're missing, it's cross multiply the two things that are diagonal, then divide by the third number. So you don't have to decide, what process I use. Once you get things put in that proportion, it's the same process. The second reason I really like the proportion method, and we'll see that in a few minutes when we do some problem solving, is as long as you match up the pieces, it helps you keep the numbers in the right place. It's actually easier to do problem solving in percents than it is, in these generic problems, because in the percents, the numbers actually stand for something. Well, the numbers that stand for the same thing have to be put together. So before we do that, as promised, we're going to go back and look at the rate method. The rate method, the first step is always convert the percent to a rate. So looking at this first one here, 35% as a rate is going to be 0.35. Now in this case, if we have the base, portion is just going to be the base times the rate. So that means here we're going to take the base, which is what we have, the 80 base amount, 0.35. And that gives us 28. That's what we had found before. That seems pretty simple. That's not bad at all. Well, let's look at the second one here. We have 125%, which is going to convert to 1.25 as a rate. We have a base of 48, so it's 48 times 1.25. That gives us 60. Well, this is looking like a lot easier method in many ways here. Let's look at the next one, the third one, 40%. Becomes 0.4 as a rate. So we take our base. It's given here of 70 times 0.4 equals 28. So far, this rate method is looking a lot simpler. And it actually is a lot simpler in problems where you are given that base amount. And in these first three examples, that's exactly what we were given, is the base amount. And we just use that rate multiplied by the rate to get to the portion of interest. It works great that way. However, we get to these other problems like these examples where we're not given the base amount. We are still going to take that percent and convert it to a rate. 80% is 0.8 as a rate. However, here we're given the portion. If we know the portion, the base is found by taking the portion divided by the rate. So here, it's that portion of 32 divided by 0.8 gives us the 40. Now it's the same answer, and it's a little bit less writing, but we had to decide, what we're given here, is it the base or is it the portion? Are we going to multiply or are we going to divide? This next example, 30%. As a rate, that's 0.3. We are given a portion of 51. So it's 51 divided by 0.3, which is 170. So that's one of the reasons why I'm not a huge fan of the rate method, or why I prefer the proportion method, is once you've changed that percent into a rate, you do have to decide, what are we given here? And am I going to multiply by that rate, or am I going to divide by that rate? Whereas in the proportion method, you just put the numbers in the proportion. Once they're in there, it'll always be cross multiply and divide. For this next one, it's a different type yet. We're not given the percent. We're trying to find the percent. So in that case, where we don't know the percent, then it is the portion divided by the base equals the rate. So for this problem, we had a portion of 63, a base of 70, that divides to give us 0.9. Now we still have to convert that rate into a percent, moving the decimal 2 spots. That's 90%. Now you can see that's a little bit more confusing, figuring out which number is the portion, which number is the base, dividing them to get that decimal rate, and then move the decimal point or convert it to a percent. Because of that, like I said, there's a lot of decisions to make in that rate method. I am a strong supporter of the proportion method because those decisions really, the only decisions there is making sure you get everything put into the correct spot. Now, with that said, I'm not saying the rate method is useless. The rate method is really most useful in applications where we know the base. Now, there's a lot of applications like this. Interest is one. You know the base amount, you know the principal. So calculating the actual amount of interest, you can use that rate method rather quickly. Commission is another one. Commission sales. Taxes, usually like sales taxes especially, and even discounts and markups. We'll look at some of those applications as we get time. Let's look at a word problem so I can show you how that proportion method helps in a word problem. FMD Corporation estimates weekly profit as 8% of gross weekly sales. Find the gross sales for a week when profit is estimated at, excuse me, $259,760. Now, there are two amounts given in these problems, and most percent problems are like this. You have amounts, and each amount is described by two numbers. It's described by a percent, and then it's described by another amount, either a dollar amount or an amount of product or whatever. So in this case, we have two distinct values that are given. One is weekly profit. The other is gross weekly sales, or just gross sales if you want. We do have the percent given here, which is the 8%. So let's start off with the 8%. Now, before I start matching things up in my percent here, we need to ask ourselves what makes sense. Does it make sense that the profit is a piece of the sales, or does it make sense that the sales is a piece of the profit? Well, it would make sense that your profit's going to be smaller than sales, that part of your sales goes to the cost of the product, the overhead, labor, utilities. Only a piece of that sales goes to actual profit. So the profit is a portion of the sales. The sales is the base amount. And the wording in the problem supports that. Weekly profit is 8% of gross sales, or 8% out of gross weekly sales. So the whole amount here, the base amount here, what was represented by the 100 is the gross sales. The 8% then represents the profit. Now, when I go to set up the other side of this proportion, the numbers I put in here have to represent the same things. So I have the number, the 259,760, Does that represent gross sales or does it represent profit? Well, find the gross sales for a week when profit is estimated at. That's the profit estimate. That represents the profit. $259,760. Because that's a large number, many people would put that in as the base amount because, well, we're not used to working with numbers that large. We feel like we shouldn't be making things bigger than that. But here it does represent the profit. It matches up with the 8%, not the 100%. Now we cross multiply and divide. 259,760 times 100 and then divided by 8 gives us 3,247,000. So we're looking at gross sales for that week of $3,247,000. Now let's look at Sam. Receives a 12% trade discount. A trade discount is a discount that one business gives to another business. Whether you're a construction contractor buying supplies from a lumber yard, because you're going to buy a large amount of supplies throughout the year, that supplier decides they don't need to make quite as large of a profit. They can give you a discount. So one, it keeps you coming through their business as their supplier, and they're going to have a high volume of sales, so they don't have to put in a lot of effort, so they don't need the huge profit. Or the same as if you're running your own machine shop, purchasing your metal and other supplies. If you're purchasing a high enough volume, your supplier will give you a trade discount because they know they're going to get a high volume of sales to you. It's going to be recurring sales. They don't have to do that a lot of effort to get those sales, so they can reduce their profit margin and still make money off you comfortably and keep you happy. So Sam here receives a 12% trade discount. How much does Sam pay for supplies listed at $1,420? Now listed, it means list price. List price is the full price. That's the amount that any customer off the street would pay. Sam gets a 12% discount, so Sam's going to pay 12% less than that. Now, many people would go to set this up. They'd take that 12%. They'd do 12 out of 100. And then the 1420 goes on bottom. Well, let's take a look at what these numbers here represent. The 100, of course, is the base amount. That's the full price. Or in this case, the list price. The 12%, though, is the discount. So we could go through with this calculation times 1420 divided by 100. Gives us $170.40. But that's not the answer to this problem. The question is, how much does Sam pay for those supplies? The $170.40, that's the discount. So making sure we keep track of what's in these proportions helps us realize that's not the answer yet. Now it gets us closer to it, because to get to the answer, all we have to do, take that $1,420 and subtract the $170.40. So what do we have here? The $1,249.60 is the amount that Sam pays. Now that isn't too difficult there, but there is a simpler way we could have gone about that. If we look at this, we took $1,420. We subtracted that discount of $170.40 and got the $1,249.60 as the amount paid. The $1,400 is the list price, $1,420. The $170 is the discount, and of course the $1,200 is the amount paid. But as we mentioned before, every amount in these types of problems is described by two different numbers. This is the dollar amounts, but each of those items is also described by percents. The list price we said before was 100%. The discount was 12%. 100 minus 12 is 88. The amount paid is 88%. We could have, rather than finding the 12% and subtracting it, we could have found 88%. If I had just set this up as 88%, or 88 out of 100 equals blank over 1420. When we cross multiply and divide there, 88 times 1420 divided by 100 is $1,249.60. So we could have got that all at once rather than having to calculate the discount and subtract. Now, like I said, in this problem here, not a lot more work to just find the discount and subtract. But there are some problems where we don't have that option. And we might have a problem like this. After a 9% discount, Pat pays $2,890 for supplies. Let's do $2,821 for supplies. I want to make this come out relatively neatly for you. How much did Pat save with the discount? Well, here we have 9% discount. 9 out of 100. Well, the 9 is the amount of the discount. That's what we're trying to find, is the amount of the discount. But the 100 is the list price. We do not have the list price in this problem anywhere. The 2,821, that's the amount paid. That's after the discount. So the 9% doesn't help us here because we're not given either of the numbers that correspond to the 9% of the discount or the 100% of the list price. So what we have to do is what we just did in that last problem, saying, okay, we have list price minus discount gives us the amount paid. The list price is 100% minus the discount of 9%. The amount paid is 91%. So if we use 91%, let's see if that works better. Well, the 100% still represents the list price. But now the 91%, that's the amount paid after the discount. And that's the number we have in this problem. We are given that Pat paid $2,821. And now to find the list price, we'll cross multiply and divide. 100 times 2821 divided by 91. Is $3,100. So the list price was $3,100. Now, of course, we're not looking for the list price. We're looking for the amount that Pat saved. In other words, the amount of the discount. So we do have to still do 3,100 minus 2821. So we'll borrow here. This is 0, 10, 9, 7, 210. So the amount of the discount was $279. Now, this problem demonstrates two things. One is the importance of making sure your numbers represent what you think they represent. In other words, represent the same thing when we're dealing with a proportion. Many of you would have done the 9%, 9 over 100, would have plugged in the 2821 here and cross-multiplied and divided. I'll show you in a little bit how that gives you a slightly different answer, which is not correct. The second thing this problem illustrates is the importance of making sure you answered the question. Often you've done the main calculation, the biggest part of the work, but you still have to go back and answer the question. Up here, we found that $3,100, but that was the list price, the full price. We still had to go back and subtract that list price and then subtract the amount paid to get the discount or the amount saved. In this question, if we had taken that 2821 and found 9% of it, nine times 2821 divided by 100 is $253.89. Now, we had $279 as our answer for the discount. So this is actually considerably off. Why is it off? Well, because we used the 2,821 as the base amount. That's not the base amount. The base amount is the list price, not the amount paid. We had to get that 3,100 as the base amount. And notice 3,100 is considerably larger than 2,800, so 9% of it is going to be considerably larger. So you have to make sure when you're doing your percents that the number that you're matching up with 100 really is the base amount. Time for me to give you some homework here. We're going to have a couple of pages for you. The first page is out of the little book. Unit 21, we'll do the odds there. The second, out of the big book. Actually, this is actually separated out into 3 pages in the big book. Page 209. Exercise 5-7A. 7 through 13, the odds. That's only, what, like 8 problems, or not even 4 or 5 problems. Page 211 through 212. This is exercise 5-8A. 7 through 15, the odds. And then the last one, page 214 through 215, exercise 5-9, again, 7 through 15, the odds. So it's only 4 or 5 problems on each of those sections out of the big book, and then the unit out of the little book. Again, make sure you're checking your answers here with percents. It can be kind of tricky. So I went a minute long here. I apologize for that, but I'll let you guys out of here and get your spots cleaned up, and we'll see you all tomorrow.